Okay, welcome to this C++ tutorial, and today we'll be looking at functions. I'm sorry that I haven't uploaded a video in so long. It's just that I was in the grasp of sickness. I almost thought I had the COVID, but it was a false alarm. But I had to be put in quarantine. This request was made by a very special lady, not Barbara, but Nyansa, very gorgeous and very beautiful. So let's get to the point of our discussion today. So here I have a simple program where I've initialized, where I have declared two variables, integers, of course num1 and num2, while requesting the user to enter those two values, and then we're adding those two values, storing the sum in result, and then printing out the result. This is basically what we're doing in our program, in our main. So let's just build and run this so that you check it out for yourself. So we'll say 4 and we'll say 8, and the sum of the numbers is 12. So that's what our simple program is doing right now. So let's take this and let's turn it into a function. So a function, this is a block of code that can be used over and over again without the need of you rewriting the code again. That's the advantage of functions. You can use them over and over again. You see that? So there are three places where you can put your function. The first place is in a different file, not in this program, but in a different file, in a separate file. The other place is above your main. You can place your function above your int main here, and the third place where you can place your function is after your program, after this curly brace here. You can place your function after your program. So today we're going to look at placing our function on top of our main. So a function has to have a return type. Any function has to have a return type. So this is let me just show you the basic syntax of a function. So a function is going to have a return type. This is what the function is returning. It's going to have a return type. The function is going to have a name, and then the function is going to have parameters. Parameters are going to represent the template holders of the values that we're going to use. These are going to specify how we're going to manipulate those values in a program. So as you can see, the parameters will act as our values. They'll only act. They're just placeholders. So a function is supposed to have a return type, a name, and parameters. And after this, we're going to have our curly braces, and within our curly braces we're going to specify the function definition. So we have a function declaration and we have a function definition. So I'll show you how to do them both at the same time, the declaration and the definition. So the definition will be what the function is supposed to do. That's the function definition. The declaration is letting the compiler know to say there's a function in place. So let's get on with it. So I'll come here on line 5. So our program is basically adding. So we're going to create our function. So what is our function going to return? In this case, we're going to return void. We won't return anything. We'll return nothing, because all we're going to do is only output. We don't want to return a value. All we want to do is output a value. So it's going to be void. That's the return type. So a return type is like a data type. So void is also a data type. So we're going to say void, meaning there's nothing it's going to return, and the name of the function, that's totally up to you. So the name of my function will be addition, of course, addition. And what parameters? So parameters, these will be placeholders. So I'll specify to say we're going to take two integers. So int a, I don't know, my neighbor's baby has been crying lately. Might be a cat, no one's sure. So int a, and we've got int b. These are just our placeholders. You'll quickly see why I'm saying placeholders. Then we have our curly braces in place. Then now, so what we've done without these two without the two curly braces, if I was to put a semicolon, this would be a function declaration. But once I add the curly braces, this becomes a function declaration and definition. So our definition will specify what this function does. So basically what this function does is we're going to take everything we've wrote in here, starting from the cout line 15. I'm just going to line 15. I'm just going to copy everything, cut it. No, not really everything. We're going to copy everything from line 20 to 23. Line 20 to 23, we're just going to take that out. Then we'll come here. Then we're going to do the same very thing. We're going to say int result in here. Int result. Then we'll say result is equal to, instead of num1 and num2, we're going to say a, b. You see those placeholders, so we're going to say a plus b, like that. Then we're going to say cout. So we're just displaying. No wonder our return type is void, because we're only displaying, we're not returning any value. So cout, then here we say sum of the numbers is, then we say result, and down. Is that result and down? Yeah, result and down. Then we come here. So we're basically done with our function. So let's just compile and run this. Boom, enter a number. So if I say 45 and I say 5, boom, surprise, it does nothing. The reason why it's doing nothing is we have no function call. So with functions, we have a function declaration, definition, and a function call. If you're working with function, you need to have these three things. So we need to call this function, and when we call this function, we need to give it values instead of what? Placeholders. Yeah. So what we're going to do here, after we collect num1 and num2, we want to call that function. So when calling the function, you don't use void, you just use the name of that function. So the name of our function is addition. So write it the same way you've written it in the declaration. So addition brackets. Now instead of providing placeholders, we're going to provide the actual values or the actual variables. So we're going to provide num1 comma num2, then semicolon. So on line 24, this in line 24 is a function call. That's a function call in line 24. Yeah. So see this, the code, this code from line 8 to line 10 that we're supposed to write in our main program is no longer in our main program. See, that makes your code simple and easier to read. See that? So that's addition. Understand? That's addition. So if after the function call in line 24, if I compile and run this, of course I say 45, then I say 5, it gives me to say the sum of the number, it gives me to say the sum of the numbers is 50 because of the function call. So without the function call, this will definitely do nothing. Yeah. Yeah, so functions make things easier. So the code, this code that was supposed to be here and increased the lines of code in the main program is no longer there, so it's here. So our function is here, and we can reuse this function several times. We can keep calling the function as we write our code. So that's the advantage of functions. So here we can add another function. We can say void, we can say void sub for subtraction, of course, sub, and we can say int a comma int b, and we can write our definition. Remember, the definition specifies what the function does. So here we can copy this same code. I'll just copy this same code, bring it here, paste the code, and instead of plus I say subtraction, then the sum of the numbers, then here we say the what? The difference of the numbers is a result. Yeah, so that's what we say once we get there. So here we have another function we're calling sub. See, we come here, instead of having wrote this code in our main program, all we have to do now is call that function to say sub, provide it with the variables we want it to work with, which is num1 comma num2, like that. So instead of writing all these codes, so here would have wrote extra 9 lines of code here, but all we're doing is calling the functions. So if I compile and run this, so enter a number, I say 10, enter, I say 4, we say the sum of the numbers is 14, the difference of the numbers is 6. See that? So that's the advantage of functions. That is the advantage of functions. So with functions you have less code in your main program, and it brings about the brilliance of encapsulation. You get to experience data hiding, because if you write your function in a separate file and the person has access to your main program, they won't be able to see the code that's in your function. So basically what's happening here is, as our program goes on, it meets this addition function. Once this function gets called, we leave this working area, it takes us to a different workspace. It brings us to this workspace here, somewhere different, not in the main program. This acts as a program on its own. It takes in the values or the arguments we've provided, it runs them through this process. After that, it's returning void, mind you. After that, once it gets to the end, the cout will do what? It will take the cout, print out the cout, and after it's done, return to the what? To the main program. And in the main program, sub is called. The same thing happens, goes back up there, and once it's done, it comes back to the main program and we end our program. So let me show you an instance where we're returning a value. So an instance where we're returning a value, we're going to do that with multiplication. So our return type for multiplication, since we're having two integer numbers, our return type for multiplication will be int. So we're going to say int, meaning it's going to return an integer, and we're going to say multi for multiplication, and it's going to take in two parameters, int a comma int b. Let's specify what this function does. So this function also have our int result. Mind you, you can use int result several times because this is only local to this scope. It's only local to this scope. So outside this scope, this won't be recognized. So that's why we're using it several times. So we're going to have int result. We're going to have int result, and then we're going to have result will be equal to a multiplied by b. Then since we're retaining something, since we're saying we're retaining an integer, we're going to say return result. So it's going to retain the value of result. So return result. And once we come into our main program, when we come to our main program here, we're going to have to say int result, or let me not stress you out with the same variable name. We're going to say int answer, declare a variable answer, will be equal to, then call that multi function. Call that multi function, give it our num1 and num2. So once we call this function mult num1 num2, it's going to bring us back up here to our function declaration and specification. That's what it's going to bring us to. So once it comes here, it's going to take num1 and num2, then multiply them. So if we have 2 and 2, it's going to multiply them. The answer is 4. It's going to store that answer in result, which is 4, and then it's going to retain that result, meaning retaining the answer, which is 4. So once it retains, it's going to retain the answer to our main program. Once that answer is retained 4, that 4 is going to be stored in our variable, which is part of the main program, which is answer. And from there you can now say cout the product is answer, which is our variable name that we just declared. So I want you to write this code step by step with me. Try to understand it, try to see what's going on here, especially to unions. So let's build and run this. So enter number, we're going to say 4, enter 2. So the sum is 6, the difference is 2, the product is 8. See that? So that's a good example of a function that's retaining something, a value. So it's retaining an integer, so that's why we had to say int. So whenever you're working with functions, you have to know what return type you're dealing with. You have to know the kind of parameters you'll be working with, or the arguments. Then you write off your function. So next time we're going to look at how to write your functions after the main, and after that we're going to look at arrays. So this is function for you guys. Yeah, so I hope you subscribe, and I hope I see you next time.